Okay, I'm going through some solutions from the mid-unit review. If you're trying to find what the cosecant of 20 degrees is equal to, you just have to remember that the cosecant really is the reciprocal of sine, and the converse of that is true as well. The cosecant of theta is really equal to 1 divided by the sine of theta. So if I have the cosecant of 20 degrees, that's going to equal 1 divided by the sine of 20 degrees. So on your calculator, depending on what kind of calculator you have, for me, I just punch in 1 divided by, and then I hit my 20 and sine. Some of you will just do sine and then 20, and hit equals. And that gave me 2.9238, approximately, to 4 decimal places. If I want to solve for an angle, when I'm given an equation like I have in 2a, the cotangent of theta is equal to 0.8701. Again, I'm going to remember my reciprocal ratio. I know that the cotangent of theta is equal to 1 over the tan of theta. So that means I could change this cotangent of theta into 1 over the tan of theta, and that's going to equal 0.8701. I could multiply both sides by the tan of theta, and that's going to give me 1 equals 0.8701 times the tan of theta. And then I would divide both sides by 0.8701, and that's going to equal tan theta. Now, what's interesting to note here is I actually could skip from this step directly to this line here. And how we do that, the shortcut to that, is I could just take the reciprocal of the left side and the reciprocal of the right side. So if I take the reciprocal of cotangent of theta, I get tan of theta. And if I take the reciprocal of the right side, I get 1 divided by 0.8701. So you'll notice these two are actually equal to each other. And at this point, we know how to find tan. How to find the theta. The theta is just equal to the inverse function of tan on that fraction. Okay, so you can put that into your calculator. For me, I'm going to actually do 1 divided by 0.8701 equals, and then I'm going to go second function or shift tan. Some of you can put that all in your calculator at one step. Just make sure that you have all of this part contained within a bracket so that it's doing the inverse function tan on that entire answer there. So that's almost 49 degrees. Let me back that up for a minute here. 49 degrees. So we're going to the nearest degree for that. Okay, and this question only asked for the values of theta between 0 and 90 degrees. If my domain was any value between 0 and 360, there's actually two answers here. The cast works with cotangent, like the secondary trig ratios as well. I know that cotangent, except I can't spell cast. Let me try that one more time. Cast. There we go. I know that the cotangent is just the reciprocal of tan, and since tan is positive in the the third quadrant and the first quadrant, the cotangent of theta will also be positive in those quadrants. So the calculator gave me that principal angle in the first quadrant. So 49 degrees would be this angle here from the positive x-axis up to there. That's our 1 theta, so I'll call that theta 1. The other answer will be in that third quadrant, and the related acute angle is equal to that 49 degrees that we found. So to get my second possible theta, if the domain was between 0 and 360, our second theta could be the 100 degrees plus the extra 49 degrees. Sorry, I said 100 and I meant 180 because that's 180 plus the extra 49 degrees right here. Okay, so that's our theta 2. It's going to be 180 degrees plus the 49 degrees, the related acute angle. And don't be shy about drawing pictures for these. It is so important to help you visualize and organize that information. People who just try to memorize and wing it in terms of just trying to know everything without actually understanding it and drawing the pictures end up in a lot of trouble with this. So make sure you are sketching these out because it really super helps in terms of understanding and organizing your information. So our two values of theta, if it's between 0 and 360, are 49 degrees and 229 degrees. I hope that helps.